You guys have heard all the talk and chatter about alternative fuels, right? Some people are talking about hydrogen, and we hear about a lot of EV stuff, to keep the planet green. I'll tell you what I think the ultimate alternative fuel is diesel fuel. You say, wait a minute, we've had that for 100 years. Yeah, but not today's diesel fuel. Today's diesel fuel is so radically different than what we had just a few years ago. It truly is an alternative fuel. Back many years ago, we had diesel. That was 5,000 parts per million sulfur. Then we had low sulfur diesel, 500 parts per million sulfur. And today we have ultra low sulfur diesel, 15 parts per million. That, along with a reduction in the aromatic content, when you overlay that now with biodiesel, B5, meaning 5% diesel coming from like soybeans or sawgrass or something like that. In other words, a bio source as opposed to petroleum. 5% minimum. I'm not saying that's everywhere, but that's in most places. B10, even up to B20. There's a couple of retailers in the Midwest. You can't buy diesel fuel from them unless it's B20. It is the way it is. We even have a couple of refiners and pipeline companies in the Midwest that you have no choice but to buy B5. They will not even sell regular diesel fuel. So all of that, Chad, simply to say it ain't your daddy's diesel fuel, and diesel fuel is not what it used to be. In fact, when we look at number 2 diesel and just what happens inside a diesel engine, this is number 2 diesel. This is just so happens is not B5. This is just straight number 2. I'm going to put an oxidizing agent in here, and I'm simply speeding up the process of oxidation. But it doesn't take very long before deposits start to form on the inside of this test tube. And that's just what happens in a diesel system. Specifically, I'm talking about the injectors and the combustion chamber. On a diesel engine, the intake valves primarily bring in air. I guess not primarily, they exclusively bring in air. So you have air that comes in from the intake valves, you have fuel that comes in from the injectors. You put that together, fire in the hole, due to spontaneous combustion. And can y'all see how that begins to build up pretty nasty, and it doesn't take very long. Now I'm going to come back to this here in just a second, but let's see if we can graphically show what's going on. I use the word in our training, I use the word oxidation all the time. What on earth is oxidation? Hydrocarbons oxidize. Maybe the best way to think about it is something that more of us can relate to, and that is if you take a piece of steel, Chad, and you just have a steel and you throw it outside and it rains on it and the wind blows on it and the sun shines down on it, what happens to a piece of steel just left to itself? It rusts. And y'all remember from junior high school, that's called iron oxide. It is a combination of oxygen mixing with the iron, and the chemical reaction is rust. Does that make sense? Same thing happens with diesel fuel. Diesel fuel doesn't rust, but it does oxidize. Y'all remember the old Pac-Man game where Pac-Man chases the ball around the screen? That really is the picture of oxidation. So here's Pac-Man, and there's the little ball that it chases around the screen. This is a hydrocarbon, and this would be O2, which would be oxygen. So what is a hydrocarbon? Gasoline, diesel fuel, transmission fluid, engine oil, rear diff fluid, transfer case fluid. All of those things are hydrocarbons, which means they're molecules made up of hydrogen and carbon. So when a hydrocarbon molecule absorbs or eats an oxygen molecule, that becomes then an oxidized hydrocarbon. So those oxidized hydrocarbons begin to link up in a process where literally what you're looking at in this test tube is liquid diesel that is becoming a solid, more of a oxidizing first and then polymerizing where it's becoming a solid. Now I've talked a lot about fuel, I haven't talked much about engines, but you know, in the day, in fact, my dad used to own a tractor shop, and back in that day, injectors would put out about 1,500 PSI. And my dad would tell me when I was a kid, he said, now be careful, you know, I've got this injector test machine and it's putting out a spray pattern out of that injector. And my dad said, be real careful, that's putting out 1,500 pounds of pressure. That'll hurt you. Today, my dad would be shocked to know that we're at 30,000 to 40,000 PSI. So we went from 1,500, which was a lot, to now plumb off the chart. But it's all about one thing, fuel atomization. Instead of having a big old drop of diesel fuel, we want a little bitty drop of diesel fuel. Think of it this way. If you were starting a campfire and you had a 12-inch log, how long would it take to light a 12-inch log and get it to burn? Like the 12th of never, right? So what do you start out with? You start out with a little newspaper, a little kindling, a little bit of sticks. You get a little bit of a heat going in there, and then you add just a little bit bigger sticks, and ultimately you get a flame to the point that you can add a 12-inch log and that'll burn. Same thing happens with modern diesel fuel. It's not just a one injection cycle, but it's literally a pilot injection cycle, or multiple injection phases to get to that combustion. So it preheats the combustion chamber. So it gives it a little bit, preheats the combustion chamber, and gets it ready for the main injector event. Does that make sense? Just like you would in a campfire. When we also look at what the business end of an injector looks like, it would look like this. Now, what's up here, the electronic parts of that injector vary greatly. Some are fully electronic. The old ones are pressure timed. There are some that are kind of a combination of the two, the piezo injectors. So what is up here is a little bit different on, as time has gone by. The business end of the injector is the same. And so it is a little plunger, and that little plunger slaps down into the cup or pushes into the cup, and that causes the spray pattern to spray out. That's how the system works. So those little injector nozzles are really finer than a human hair. I mean, very, very small. I guess here's where I'm headed with this. It doesn't take much of this to plug up that. Does that make sense? It doesn't take much. But there's something I've always struggled with here. What's the pressure on these injectors? What's the pressure? Yeah, 30 to 40,000 PSI. So think with me just a minute. Let me graphically draw out this injector. If this is the injector here, like this, and this is the injector wall, and we go down here like that, you'll see where I'm talking about. This is the injector. The plunger sits right in here. Does that make sense? So if those deposits build up here and here, what again is the pressure coming out of this? 30 to 40,000 PSI. Chad, would I be on firm ground if I said, there's no way deposits can form here with 30,000 PSI of pressure blasting that thing off? I mean, it defies logic, right? Here's the rest of the story. When you shut that engine, by the way, these deposits are not formed at that time. So when are they formed? When you shut the engine off. When you shut the engine off, immediately what happens to engine temperature? It goes up. So what's down here in the combustion chamber? And this injector is in the combustion chamber, right? So right when you shut the engine off is every bit of diesel fuel completely burned up in the combustion process, or is there some left over? Some's left over. So you have diesel fuel and air, oxygen, swirling around here for a long time. After you shut that engine off, guess what? It begins to deposit itself here and deposit itself in here. That's how those deposits are formed. They're formed more when the injector is idle or when fuel is not flowing through it, and we build up the deposits, and this continues to build up. Now, one of the documents that I'm going to give you at the end of our presentation actually shows a camera microscopically looking at these deposits before you do the service and after you do the service. And some of those photos, when you're looking at this head on, like this right here, in other words, when you're looking at that hole, you're going to notice that some of those holes, they look about 99% plugged up. When you look at the after, it is the most amazing thing. It's going to clean that out. So this service is about blowing its nose. It's about cleaning all of this stuff out of these micro passageways so that when you're looking at it, it goes from this to this. Does that make sense? That's what this service is all about. The product that we use is called FSPR. You guys have heard of EPR, Engine Performance Restoration. In fact, you might have drank our little drink, HPR, Human Performance Restoration. Well, this is FSPR, Fuel System Performance Restoration. Here's the most amazing thing about this product. We're going to pour this into a 50-gallon, up to a 50-gallon tank. I mean, if it's got a 35-gallon tank, we're going to pour it in there. 40 gallons, 45. So we're talking like a Ram pickup. We're talking about a F-350. We're talking about a GM Duramax type vehicle. You know, a passenger pickup is what I'm talking about. One bottle goes in. That vehicle drives 500 to 700 miles, and these are the kind of results that we get. So in Oklahoma, this has actually become our fuel system service. This has become our injector cleaning service by dumping it in the tank and having it clean out these passageways like you're looking at here. Let me see if I can graphically show this to you. I'm going to pour out the diesel fuel that I had. I'm going to add a little bit of this FSPR. And again, what I'm doing here is not scientific, gentlemen. I'm just painting a picture of what goes on in that fuel system. Because it goes into diesel fuel, I'm going to put diesel back into our tank. Remember, this is not a quick product. This happens over mileage and time. Now, I'm not sure you can see that from where you are. It is remarkably cleaner, but it's by no means clean yet. Does that make sense? So we're going to keep working on this. Remember, this works over a tank of fuel. You know, if you have a 40-gallon tank and it gets 20 miles per gallon, you know, that's going to be about 800 miles. You know, somewhere between 600 to 800 miles a gallon, for a tank of fuel. But you notice how that's beginning to clean. In fact, the stuff that was easy to clean is clean. We've got some heavier deposits right there. Can you see that? Some heavier deposits that we're still working on, and just a little bit of a deposit in the bottom, but we're getting it. So this is not the kind of service. So you're going to sell this, by the way, as a diesel injector cleaning service. That's what we sell it as in Oklahoma. When you sell it and they put you guys as technicians put that bottle in the tank, the customer's not going to drive out of here and feel it in the seat of their britches right then, because it is going to take a while to get this cleaned up. I'm just about there. You'll see that? But the thing that I really want to brag about here is look at the bottom of the test tube against my shirt. Do you see how there's not a little pocket of trash in there? It's not like we knocked all these deposits loose and sent them somewhere else. This is a detergent dispersant that goes in to clean up those deposits and totally remove them. Detergent means cleaning, dispersant means hold it in suspension. So Chad, I gotta ask you as a professional technician, if FSPR will do what you've seen it do, I think you can see that that's a must as part of any diesel fuel service you do, isn't it? And that's where we'd ask you guys to do that. About once a year or every 15,000 miles, the fuel injector service using FSPR. Okay, by way of setup on this demo, just a couple of things that you need to know. When I did my drawing here, so I hope you can picture what I'm talking about here. This is the plunger coming down. These are the deposits that form when the engine is shut off due to elevated temperature and the hydrocarbons swirling around. And these are the before and after pictures. I used the case study that BG put together on the various vehicles like the Dodge Ram. You've seen those case studies. They're on dashboard, and I always hand that out at the conclusion of my presentation so they can see that. I do think that understanding oxidation, I think, is fundamental to everything we do at BG. It is this law of physics, quite frankly, that has made us and our shops an awful lot of money. And again, the way I described it, oxidation of a hydrocarbon is no different than rust with a piece of steel. So I think that's the way that you want to explain that, like the Pac-Man game. Again, I think this is just required explanation of any BG professional. The last thing I would tell you is, you noticed I did not heat this. I put in diesel fuel, 2 drops of acid, swirled it around. It was very nasty. Dumped it out, go back in with FSPR fresh diesel, and you see how it gets it flawlessly clean. Do not use heat on this. If you add heat to it, the demo is not going to work right for you. You're not going to get it as clean as you want, and it's not going to make your point.